In 2023, as Sam Altman was touring the world talking about artificial intelligence, he was asked this question in India. Some venture capitalists asked him if some small funded startups, let's say in India with a budget of $10 million or under, could hope to compete with OpenAI's models. Could they build something as noteworthy as GPT-4, for example? Sam Altman's answer was basically that this was unlikely, that basically you would not be able to compete with OpenAI on foundation models. Fast forward a few years and we have DeepSeek, an open source model out of China trained for about $6 million that is pretty much as good as o1, the best released OpenAI model. And the world is kind of reeling to understand the impact of this. What does this mean for AI progress, for open versus closed source, for US versus China? So let's dive in. So first and foremost, Eric Schmidt, ex-Google, he tends to be pretty good at predicting sort of the tech future. He recently posted an article in the Washington Post talking about this specific thing. Now, keep in mind, we've had some of his interviews on this channel with basically clips of him talking about a lot of this. He was a little bit ahead of this, specifically on where China seems to be going. The article is called, "Will China's Open Source AI End US Supremacy in the Field?" AI moves fast, but even the people that are following this stuff were taken by surprise by Chinese company. Of course, that's DeepSeek and their model, the R1, although there are a total of 3 models that they released, each one of them fairly interesting, fairly special. Actually, there's more models that they've released that are kind of distilled models, but those 3 are sort of the core models. The R1, R10, and the V3. Each very interesting for their own sort of purposes, but R1's sort of like the star of the show. This is what everyone's talking about. And of course, it's on par with OpenAI's o1, their best reasoning model that's currently released. Running this new model super cheap, about 2% of what OpenAI charges. Shortly after that, DeepSeek also released Janus Pro to compete with the DALL-E 3, so you're able to run it on your local machine to generate AI images. And of course, DeepSeek's entire collection of models is open source, right? So they provide the open weights, so sort of the brain of the AI, meaning people can reproduce it, people can build on top of it. At the same time, most American firms do not open source their models with the exception of Meta. Grok has been open sourcing some of the models, so we'll see kind of how that continues. Grok is, of course, XAI, Elon Musk. And of course, for the longest time, closed source models that were built in the United States, they were the best. They were the frontier models. Open source and Chinese models were thought to be months behind. This was the case up to literally a few days ago. Here's the Chatbot Arena leaderboard where people kind of vote on which models they prefer without knowing which model they're interacting with. And for the longest time, as far as I can remember, as you kind of go down the ranks, all of them was usually proprietary, closed models. You had to go down quite a ways to see an open source model. This is the first time that I'm seeing an open source model this high up on the list. If I'm getting that wrong, let me know in the comments, but I don't remember at any point an open source model being this high up, competing basically neck to neck with the best of the best models, with GPT, with OpenAI, with Google, with Anthropic. And of course, these news caused the US tech stocks to plunge. Globally, we had a loss of $1 trillion in the various markets. NVIDIA in and of itself was responsible for about half of that. Now, of course, a lot of that bounced back since, but people are still reeling, trying to figure out what this means. Now, imagine kind of these 4 quadrants with US and China and open and closed. So far, up until now, the dominance was here. There was US models that were closed. We had a few good open source models, but in general, if you were looking at the best of the best, they were US and they were closed. They were proprietary. And then one day, a few days ago, basically overnight, we shifted from US to China dominance and from closed to open source. Now, that might be putting it a little bit too strongly. It's not like China completely won the race and open source completely won the race, but they did catch up very, very fast. And it's important to understand that given the choice between 2 equal models, one proprietary and one open source, you'd be hard-pressed to think of use cases where the proprietary model might be better. open source is going to be much cheaper, much more customized. There's going to be less restrictions in general, less control. The community of developers and people that are working kind of within that ecosystem will likely be much, much greater. And the open source advocates argue that transparency, allowing everybody to build on their work, having that sort of open source system where all the developers can contribute, it can enable these systems to rapidly catch up with larger closed models. If the open source thesis is correct, this would turn the AI ecosystem on its head. And again, so this is written in part by Eric Schmidt, somebody that has been very right about kind of his tech projections in the past, how he views where the future might be going. It's somebody that has a very strong voice in the space. People listen to him. He's an authority figure, somebody that people look to for advice and guidance. He's saying, look, the United States has the best closed models in the world. But to remain competitive moving forward, we must also support the development of a vibrant open source ecosystem. We have expert controls that are aimed at choking off China's access to the most advanced computer chips. Right now, it seems like that might not be working that well. It does seem that these various Chinese startups have a lot more NVIDIA chips than we are aware of. Now, those are sort of like the rumors around the campfire, so to speak. But even if there is a sort of a limited access to these high-end AI chips, it might have pushed the nation's companies and researchers to be more efficient and led them to uncover new technologies that significantly reduce training costs. So this idea that if we limit access to a resource, the people become creative, they become more efficient with that resource, right? So we don't give them as much compute as the American labs. And the assumption was that that would cripple their ability to be competitive, right? So as Meta and Google and Microsoft and everyone else are buying more chips, unlimited amount of chips, limited only by their availability and the company's budget, and basically just scaling up and up and up. The thinking was the countries that don't have access to that will not be able to produce models that are as good. DeepSeek really seemed to have kind of like broken that thesis. The R10 that we've covered in the previous video, they have a research paper kind of outlining what they're doing. Basically, they're removing some of the human training and having it more train itself. So we've seen some of these ideas in Google DeepMind where the models that are taught to play chess or Go or any of those other games, when they're taught on human data, they get good, they get very good. But when we don't use human data and instead let them create their own data, engage in self-play, and just kind of play billions of games against itself, creating those games, oftentimes it will come up with new, never before seen strategies, things that might look alien to us. You might have heard references to Move 37. This is when AlphaGo, right? So Google DeepMind, right there, sort of Go playing AI, was matched up against the best Go player in the world, Lee Sedol. And at some point on Move 37, right, this AI makes a move and you see there's a lot of people watching, right? The commentators, it's broadcasted live. There's people there. There's people commenting from home on a live stream. And you see this confusion. They're looking back and forth. They thought, oh, did we get that right? They're kind of like trying to figure out what happened because the move looks bad. The move looks weird. It looks wrong. If you're a young student learning from a master and you made that move, the master would say, I wouldn't do that. That's the wrong move to make. It's just bad. So you see people kind of like laughing, thinking, okay, AlphaGo really screwed this one up. But of course, it goes on to win and beat Lee Sedol completely. And only towards the end of the game, we understand kind of the brilliance of that move and why it was so pivotal. It was referred to as creative, brilliant, also alien. It's not something that we have in our repertoire of moves, let's say. So with R1, they bypassed the traditional supervised fine-tuning stage. Supervised, basically, you can replace that with thinking human. Unsupervised, no human. Supervised, human involvement, whether that's a data, labeled data, or something of the sort. Reinforcement learning of human feedback, RLHF, or you can also have reinforcement learning with AI feedback, where AI acts as a judge. You can also have human-made data, like for example, with chess or Go, human games that have been played before, versus synthetic data, where the AI generates its own data either by self-play or with a lot of these models with the R101, it generates reasoning about how to solve certain problems. That's synthetic data that can be used to train the next generation of models. And in general, not just here, but a lot of other news that we've covered here, as we move from sort of like human supervision to this AI training itself, more and more that seems to have great results. There are certain like emergent abilities that are very surprising, very effective. It's a little bit more wild and chaotic. Like it's not as sort of structured as when we use human data. It sometimes goes off and does weird stuff. But there does seem to be a lot of power there, a lot of potential for training these models. And the DeepSeek's success also called in question the importance of pre-training. And this is if you were wondering why the NVIDIA stock dropped so much. Pre-training is where NVIDIA and the GPUs, where they reign supreme. So really fast, so we're on the same page. So for the longest time, we had pre-training. This was sort of like the biggest part of creating these models. This is where we get the gargantuan amounts of data and we feed it into the model. And over time, that model sort of like changes and shifts its neural nets, its brain, to be better able to sort of make predictions or inferences about that data. Next, we have post-training. So after the model is sort of cooked, after it comes out of the oven, we still have to do some post-training. So this is actually a great way to visualize it. So you have your data set. So let's say for large language models, it's like everything on the internet, all the books, textbooks, whatever, right? So we have our pre-processing of the data, filter out the bad stuff, the low quality, maybe add synthetic data, etc. We have pre-training. So that's kind of like before that was the biggest chunk. So this is where NVIDIA goes burr, right? All the GPUs go burr. Then we have post-training. So this is where after the model's not done, but it's like it's out, then we continue to kind of like fine tune and massage it, doing some post-trainings. We've talked about, of course, RLHF, so reinforcement learning of human feedback. So you can think of that as like, if it gives you an output, you go, good job, you did that really well. You hit the thumbs up button, or it says something wrong. You're like, no, thumbs down, don't say that. So that's reinforcement learning with human feedback. And supervised fine tuning is where a human being kind of demonstrates the wanted behavior. So SFT, right? So remember that acronym, supervised fine tuning. Supervised means human labeled, human is involved, right? So a prompt is sampled from the prompt data set. Explain the moon landing to a 6-year-old, right? Then a labeler demonstrates the desired output behavior. Some people went to the moon, blah, blah, blah. So a human being sort of demonstrates it. You can also think of it as with translation, right? So if you have a sentence in English and you give it like the translation into French, that would be kind of the labeled data set. So that can be used for supervised fine tuning, right? And that data is used to fine tune GPT-3 or whatever model we're talking about. As you can imagine, this has some issues, right? So again, it's human data. We believe that these models can learn far better, eventually without human data, although we're still figuring out how to do that effectively. We've figured out how to do that extremely well with, AlphaFold, AlphaGo, etc. But in terms of large language models, it's still a work in progress, although we're seeing some good results with it. Another thing, obviously, it's not as scalable. It's expensive. You need humans, living, breathing humans sitting there labeling data or, providing sort of the desired output behavior. And then also in the post-training, we might have direct preference optimization, DPO, knowledge distillation. We might come back to that. But the point here is, so that's post-training, right? And then we have inference. That's where it actually gives us the answer. Where it goes, well, based on everything I know, I think it's blah, 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 blah. The answer, the inference, the prediction. So again, pre-training is where GPUs kind of reign supreme. This is where NVIDIA makes why NVIDIA is doing so well. None of this is investment advice. I hope that's clear. Now, everything else requires GPUs as well, but for inference, NVIDIA isn't quite necessarily the end-all, be-all. It doesn't have as strong of a moat. And that's because, for example, we can have something like the Grok chip, a fairly newcomer to the field. That's, they call them the LPUs, the language processing unit. The GPUs, so NVIDIA's sort of reign was incredible because they built something capable of parallel computing. And in the beginning, they were doing it so we can all play video games, 3D shooters really, really fast, right? As you're running around in Quake 2 trying to frag somebody, right? You don't want the computer sort of doing like one pixel processing at a time. You want it to process the entire thing so they can play it blazingly fast, right? Then the crypto wave hit, and of course GPUs were great for that as well. Then the AI wave hit, and GPUs were great for that as well. And then the next big wave we're expecting is robotics. And it certainly sounds like the GPUs can be great for that as well. It's an incredible kind of all-around good technology. But For very, very, very specific use cases, like where you just want this thing to spit out words as fast as possible, there might be other chips, other architecture that might be better, like the Grok chip, LPUs. There's a number of other ones. That's kind of like the most, as far as I know, like the most promising competitor, I guess you could say. So here's kind of a chart showing roughly where you expect this to fall compared to GPUs, right? So again, the point is that how it used to be is GPUs, NVIDIA, it was just great across the board. It was like a perfect kind of workhorse that did everything, kind of general purpose parallel computing. And yeah, maybe there was like a little bit more other architectures that could be faster specifically for the inference part, but that wasn't kind of like the bulk of the stuff that was needed, the bulk of the compute. Then we get the, you know, Q-Star, Strawberry, or O1 model, like whatever, they had different sort of names throughout the sort of cycle, right? But it's basically the O1 model. It's the reasoning models, the models that have a kind of a hidden chain of thought, or it's, you know, in the case of the R1, it's actually not hidden. You can see it with the O1, OpenAI's model. It is hidden. We, the users, cannot see it, right? But the point is the pre-training with those isn't sort of as important because we allow it to think longer. So the inference, we're allowing it to run for a longer time, thinking through everything for longer. And this allows it to do much better performance on various stuff, specifically math, coding, stuff like that, the stuff that these models tend to dominate in. And so again, here, GPUs are great across the board, but the number of other architectures that could be used, you know, chips specifically designed for large language models, that kind of faster inference, there might be more room for other competitors to step in. And this, the whole thing is before the R1. So the R1 comes out and they're like, you know how much it costs you to, you know, do pre-training on a model, where it cost us like 45x less, right? So it's 45 times cheaper to train this model. Oh, and the inference cost, the cost of running and having it spit out its data, its thoughts, its outputs, right? It's like 2% of what OpenAI's O1 is. So I've heard a few different numbers, 93% cheaper. I think one of the people said 93% cheaper, or somebody said it's only 2% of whatever they were comparing it to. The point is it's much, much, much cheaper, much more efficient. Oh, and the other thing they did is they did something with the post-training, right? So that idea of supervised fine-tuning, right? So with the R10 model, they also had, I would say, a breakthrough there. So this is the DeepSeek R1 paper they put out. And here they talk about their DeepSeek R10 model, a model trained via large-scale reinforcement learning without supervised fine-tuning. So remember, supervised fine-tuning, that's part of the sort of the alignment, right? SFT, that's sort of that labeled supervised human data, sort of demonstrating the desired output. So we sort of cut out the need for human labeled data. So they trained it without supervised fine-tuning as a preliminary step. That model demonstrates remarkable reasoning capabilities. There emerges naturally, right, with numerous powerful and intriguing reasoning behaviors. We've covered this in previous papers, so I'm not going to go through it again. But kind of like the big thing to grasp here is how sort of our ideas about how AI works, how it's changing, how our view of what this progress is going to look like, how it's changing. And this is not just this one company, not just this one research paper. We've been seeing more and more of this idea popping up. And that idea is, before we thought, like, how do we humans, how do we explain to these things how to solve problems? Like, how do we make it understand? How do we like explain it? How do we code it or whatever to make it do the thing? But now more and more we're thinking, no, that's not the best approach. The best approach is, how do we make it itself figure it out and come up with its own sort of solutions to the problem? So they kind of refer to this process as self-evolution, right? And during the self-evolution, there's emergence of sophisticated behaviors, such as a reflection, where the model revisits and reevaluates its previous steps, thinks through alternative approaches, etc. This is the big point to understand. These behaviors are not explicitly programmed, right? So we're not coding, we're not programming it to do it, but instead emerge as a result of the model's interaction with the reinforcement learning environment, right? So it sits there, it thinks through solutions, and it has its aha moments where it's like, I got it, eureka, right? I know how to do this, I get it. All right, not to overstress the point, but here's last sentence. So this idea, right, that we just talked about, the aha moment, the self-evolution, right, it underscores the power and beauty of reinforcement learning. Again, reinforcement learning is thumbs up when it does something right, thumbs down when it does something wrong. Basically, obviously, it's more complicated than that, but just when you hear reinforcement learning, it's kind of like positive rewards for doing certain behaviors and also usually negative rewards for the wrong behaviors. So they continue, rather than explicitly teaching the model on how to solve a problem, we simply provide it with the right incentives, right? So thumbs up, the right incentives for doing the right thing. And it autonomously develops advanced problem-solving strategies. And this is paving the way for more autonomous and adaptive models in the future. So the DeepSeek model comes out and it's like pre-training, 45% cheaper. Inference, whatever, 93% cheaper, 98% cheaper, whatever the actual number is. I guess it depends on what you're doing, but somewhere in that sort of ballpark. Also the R10 model, right? So that's the one that did the post-training improvements with the supervised fine-tuning. So that whole idea of it, like, let's figure out how to have it teach itself how to do it, self-evolution, have it make its own aha moments, etc. So you can probably see why this is such a big deal, while everybody's kind of like reeling from the impact of these DeepSeek models. So to the people that's saying, well, why is NVIDIA down, right? Yeah, maybe there's less pre-training, but there's still more inference. So GPUs do inference. So isn't that good for NVIDIA? Again, one of the explanations for that is sort of this changing, like there's more inference. Inference can be done by other chips. I'm not saying that's right. I'm not saying that's wrong. I'm saying that's sort of the reasoning that some people might give you for why that's happening. The other thing that people are talking about is saying that, okay, so if, it's now 45 times cheaper, so let's call it this thing got 50 times cheaper just for the sake of the argument. People are saying, well, if it now is 50 times cheaper to train these models, doesn't that mean that NVIDIA's demand is cut by 50 times? Or maybe some fraction of that, right? Maybe like 25 times, whatever. We've seen some people basically say more or less that. To me personally, this is just my opinion, take it with a grain of salt. That does not make any sense. Like genuinely, this does not make any sense. That reasoning does not make any sense. And part of understanding that is Jevons paradox. You probably know intuitively, you've probably heard of this concept before. Maybe you didn't know what this was called, but so the idea, like for example, fuel efficiency, the better the fuel efficiency gets, that tends to increase fuel use. So if you spend 10 gallons a week driving everywhere, right, that's sort of your average consumption of fuel. And then you get a car that, all those same trips cost 1/10 of that, right? So it's only 1 gallon to get everywhere where you used to go. You'd assume that the amount of fuel that you use is decreased, right? Because you can get there with less fuel. However, paradoxically, sort of the opposite might be true, and you end up using more fuel, right? So you're like, oh, wow, this is so cheap to drive everywhere. Let me drive to more places. Let me drive around more. So in other words, your original driving habit might be here if you're driving a regular car, but if you get a hybrid car, you might have a new driving habit where you drive more. So the question really is, how much more of that thing would you want if it's much cheaper? So for example, I have some number of pillows in my house. If tomorrow all pillows go on sale for half price, I'm probably not going to get more pillows. Not something I necessarily need more of in my life at any price. If, however, salmon sashimi goes on sale tomorrow across the board, I will likely make myself sick because I will eat a lot more of it. Probably one of my favorite foods in the world. Get a little soy sauce, wasabi on there. Wow. But not from just any random old place. You gotta like not everybody knows what they're doing. It's a certain places that know what they're doing where like just really, really hits. And the cheaper it gets, the more I will eat, probably up to a point. So there's some sort of point at which I'm like, all right, no more of the salmon sashimi for me for today. So that's called the price elasticity for all you econ nerds. So I think the question is here between, pillows and sashimi, where does the price elasticity of intelligence falls? If intelligence goes on sale, do you buy more? And how much more? Well, Satya Nadella saying Jevons paradox strikes again. As AI gets more efficient and accessible, we will see its use skyrocket. Imam Mustak saying the same thing. After we released Stable Diffusion as an open source, smaller, faster, better version of the closed image models out there, it completely used up all GPU capacity on clouds. The point here is that cheaper AI equals to more profitable AI use cases. Would you pay $10,000 to have a super intelligent thermostat in your house? It would always have like the perfect temperature for you throughout the day, throughout the night. It was just like this super genius thing that's capable of making sure you are at your most comfortable while also, saving energy. How many people would pay $10,000 for that? Maybe some people would, some buildings that have a lot of expenses like that would help them. At $1,000, you'd also be getting a lot more businesses, probably some households with special, people with a lot of disposable income might buy it. How about at $10? At that point, most of the people I feel like would get it to never have to think about it ever again and also save money. The super intelligent thermostat company, if it costs them $10,000, well, it's kind of this niche case service business, right? Where if it costs them $1 to make, that could be a unicorn company, right? Because basically getting installed that in every house in the world, potentially, because every house with an AC or heating system might be interested in something like that, especially if it really contributes to energy savings, decrease of waste, etc. Do you remember Marvin, the paranoid android from the Hitchhiker's Guide to the Galaxy? He's always depressed because he's got the brain the size of a planet, right? He's this super intelligent robot, but he's tasked with mundane jobs such as opening the door. So we already know that artificial intelligence is getting better and better. We're now seeing it become much, much cheaper. So again, assuming that everything that DeepSeek put out there is correct, all numbers are correct, then I would expect the consumption of intelligence to go up and up and up. A lot of people are saying is going to squeeze sort of the profit margins of certain companies here that are selling either these models through an API, or the people that are providing cloud services or whatever, or that the companies that purchased a lot of GPUs, sort of like that's wasted. To me, that seems a little bit like we're assuming just demand stays flat. So GPT-4, we believe, right, there's some rumors that it cost $60 million to train, right? We also know that a lot of people used synthetic data from GPT-4, the outputs, to train their own sort of models. OpenAI probably used, some of the synthetic data from that to build their O1 model. Let's say that model cost $45 million to train. I'm just guessing. Don't tell me that this is completely off. It's probably off. It's probably less due to the various advancements that have happened, but I'm just picking that number out of a hat, right? So O1, let's say it's 45, right? Then we believe, we are fairly certain that they used a lot of the outputs from the O1 to build the O3. A lot of people are wondering what happened to the O2. I was kind of wondering myself. Apparently O2 is somebody else's trademark, some mobile communications company or something, whatever. So they couldn't say O2. So they went from O1 to O3, right? So maybe that cost them 45 million as well, whatever. We're just assuming sort of the costs are static for now. Now, we know based on a recent interview that one of the executive leaders there did that they are now training the next model, right? So that's confirmed that there's an O4 in the works. Let's say that costs 45 million, right? Since they already started training it, etc. Again, the belief is that sort of the O1 model, its reasoning provides the synthetic data for the next model. So the O3 is much better in part because it was built on the O1 reasoning. The O1 is good at producing reasoning. That good reasoning makes for a better model when used as, training data for that model. Then the O3 model can produce even better reasoning, which makes it even better able to produce the next generation of models, the O4 or whatever they're going to call it. You get where I'm going with this, right? So let's say the next model that they produce is the O5, right? I don't know what their naming convention is going to be. They're always just completely off the wall. Let's kind of assume like the relative cost is about the same for these models, right? But guess what? They look at all the DeepSeek, the algorithmic breakthroughs that they've had, and they go, hey, wait a minute. They were able to build this model for 45 times cheaper than the equivalent models that we're building, right? So all of a sudden, how much does O5 cost? Well, wouldn't that mean we can probably build it for $1 million? Let me know if I'm missing anything here, right? So provide me your reasoning why this might not be correct. If I'm missing something here, let me know. But also think about this. What if another startup wants to compete with OpenAI? How much money would it take for them to catch up to the O4? well, what is this, around 200 million, right, to produce all of these models and kind of get this ball rolling of improving the different models. Because remember, when GPT-4 came out, we're pretty sure everyone else was taking data out of it to build their own models. DeepSeek V3 does say it's running on the OpenAI architecture, if you ask it. In a previous video, I've shown that because they took the synthetic data out of that model to build the DeepSeek models. There were some people at Google that said that maybe Google did a little bit of that too. It was a little bit of a commotion at a time, but who knows? It's not confirmed. Grok also sometimes is convinced it's running on OpenAI architecture. So Grok also might have been engaging that practice a little bit, right? So everyone was siphoning off GPT-4, but with the O1, that hidden chain of thoughts, it's hidden, so we don't have access to it. So maybe that's not going to be quite as easy. Maybe if you want to get this ball rolling and start compounding the models, you might have to, shell out X amount of dollars for each and every single one of them. If it's 200 million to catch up, well, that's extremely, extremely prohibitive. If it's like 5 million, there's going to be a lot more startups kind of gunning for the space. That's just my opinion. That's my 2 cents. Let me know if I'm wrong. Just tell me why. Am I missing something from this chart? Keep in mind also that, for example, Hugging Face is trying to replicate the R1, calling it the open R1, right? So open training, open eval, open data, open weights. How many other companies will try to reproduce something similar? Here's Zhao Sun, research scientist at Google DeepMind, right? So one of the things that she's super excited for this DeepSeek R1 model and models like it, what it's going to be able to unlock is that it allows for exciting opportunities for example, PhD students with limited compute to explore further. If you are, as they say, GPU poor, right? So you don't have access to a lot of GPUs, like you're in the academia, right? There might be some strict limits to how much you can get for your projects. Running the sort of the experiment that you conceive of might not be viable, right? So you don't have enough, so you don't do anything. You give up on that project, you do something else. With cheaper compute, with more efficient models, all of a sudden you might be able to run that project. As companies and universities see more and more of these projects happening, they see sort of the ROI on doing research like this. Do you think they'll want more compute or less compute? So Eric Schmidt is calling for a more robust open source ecosystem in the United States so that we maintain our advantage. We still should have our closed proprietary models, but we also need the open source models to compete as well. Sort of a natural sort of balance in that ecosystem. Why is that important? This is why it's important, right? Here's Sam Altman saying DeepSeek's R1 is an impressive model, particularly around what they've been able to deliver for the price. We will obviously deliver much better models. And it's also legit invigorating to have a new competitor. We will pull up some releases. Powerful open source models like the R1 do a lot of good for everyone. Sam Altman and OpenAI, if they're able to replicate the algorithmic breakthroughs that they did, which are fairly open, like they can read the paper, like they're going to be able to copy some or all of them. That's obviously incredible for them, right? For free, they're getting these massive breakthroughs just by reading a paper. Will it put pressure on maybe some of the profit margins? Yes, but it's also, reducing a lot of their expenditures for building these models. Like they're going to be fine. They're still going to keep doing their thing. But as they say, it's legit invigorating, right? So it's going to put some pressure for them to release faster. They're already saying we will pull up some of our releases. We'll release stuff faster. Not only that, but we're going to be, releasing better models as well. President Trump referred to this as kind of a wake-up call. I don't know if he was the one to use this phrase or not, but someone was referring to it as the Sputnik moment. The Sputnik moment is, of course, when the Russians launched the first Earth-orbiting satellite, the Sputnik 1. And that was kind of a big wake-up call for the United States because they realized that they were falling behind. This invigorated, the research, the production, the scientific community to do more, to go even farther, to accomplish that sort of next frontier. If DeepSeek is AI's Sputnik moment, do you know where that means we're going next? Yes, to the freaking moon, baby. Get your space boots ready. If you made this far, my name is Wes Roth. Thank you so much for watching, and I'll see you next time.